Hi student, today I'm going to start new exercise that is definite integral. You are very much familiar with indefinite integral. Here we are going to start definite integral. Okay, this word itself says that there is nothing. It means there is nothing unknown, means we are not going to add any constant c here as we were doing in indefinite integral. So here no need to add c. Okay, another thing, here we will get unique answer. Okay, in indefinite integral, in case of trigonometric functions, answer may varies, we have seen, but in definite integral we are going to get definite answer. Okay, now definite integral we will study in two forms. First one as a limit of sum. We will discuss this topic only right now. And second one as antiderivative, capital F, in the interval a comma b. So one by one we will see. Today we will see this as a limit of sum. This is a small concept, but in CBSC most of the time they have asked questions from this. So we should not neglect this. Now let us understand what is limit of a sum. This is one. I have drawn one diagram here. I'm going to draw one curve. This is f of x, and suppose here to here, this is here to here, this distance is a, and here to here, this distance, this is b, this is b. Okay, I have to find the area bounded by this curve, this x equal to a and x equal to b, and x-axis. Between this means this region area we have to find. So we don't have any formula of this kind of figure. We have formula of rectangle, we have formula of triangle, we have formula of trapezium, we have formula for quadrilateral, but this is not a quadrilateral since this is a curve. So what we are going to do, we will divide this area into small equal width. Width is going to be equal, height may varies. Okay, see, so everyone's width is h, is also h, so everywhere h. Okay, now see here, can you see here, if you consider this is not a rectangle actually, so we cannot apply the formula of rectangle. See here, okay, So here we can, if we name here, see, so no need to name, just understand here. Okay, name it. Later on it will be easy for me to explain, so name it. Just give here A, B, C, D, E, F. Now if we see here, then area of, by seeing the diagram itself you can see area of E, sorry, yes, EFDC is less than area of BFDC, and area of BFDC is less than area of ABCD. See here, this area will be less than this area, and this area will be less than this bigger rectangle. Okay, but we don't have formula of this kind of figure. Okay, it is not a rectangle. So when it will become rectangle, when this you can imagine, just imagine, when this distance will be very less, this h becomes very less, then this will be one thin, very thin rectangle. Yes or no? You can imagine. Okay, so here when, so when this h, when h will tend to 0, then this will become a perfect rectangle. But when this h will tends to 0, when this, when I will divide this whole area into very small, into very small rectangle, means when n tends to, see this is, क्या है कि ये पूरा एरिया को हमने छोट n रेक्टेंगल में बांट दिया, ठीक है, n 1 2 3 4 5, यहाँ पे 6 ही रेक्टेंगल है, n इक्वल टू 6 है। तो जब हम n अगर बढ़ाएं, n इक्वल टू 8 करें, 10 करें, 100 करें, इन्फिनिटी करें, तो क्या होगा, n जब इन्फिनिटी होगा तो h क्या होगा, 0 की तरफ जाएगा। सो when n tends to infinity, then only h tends to 0. Okay, when n tends to infinity, then h tends to 0. ठीक है, अब हम यहाँ से देख सकते हैं, यहाँ से कि ये जो b है, b, ये डिस्टेंस यहाँ से ओरिजिन से लेकर के b तक का, तो b इक्वल टू क्या है, b इक्वल टू यहाँ से a, b इक्वल टू a प्लस ये डिस्टेंस, ये कितना है, सभी विड्थ कितना है, h है, तो कितने हैं ऐसे n है, तो कितना है, NH है। टोटल डिस्टेंस कितना हो गया, यहाँ से यहाँ तक NH प्लस a, तो b इक्वल टू NH, b इक्वल टू a प्लस NH है। Okay, therefore from here we can get NH is equal to b minus a. This implies n is equal to b minus a upon h. Okay, you have to understand the concept, that's all. Okay, so now we are going to find the area of this one. So how, a to b, मतलब यहाँ से लेकर के a से लेकर के b तक ऑफ किसका, ऑफ दिए हुए कर्व, a bound by curve, and f of means x equal to a, x equal to b, and this x axis. ओके, इक्वल टू क्या लिखेंगे हम यहाँ पे, लिमिट h टेंड टू 0। अब सभी छोटे छोटे रेक्टेंगल को हम रेक्टेंगल के एरिया को ऐड करेंगे। एरिया क्या होता है, लेंथ इनटू ब्रेथ, तो ब्रेथ तो सबका कॉमन है, h है, h बाहर ले लिए। अब लेंथ की बात आई, तो पहला लेंथ कौन सा है, ये वाला एफ ऑफ ए होगा, ये एफ ऑफ ए। दूसरा लेंथ है, हम उसमें क्या करेंगे, एक एक करके ए ऐड होता जाएगा। ये क्या एफ, ये तो एफ ऑफ ए आ गया, यहाँ 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 से आ गया। दूसरा है ये विड्थ है, दूसरा विड्थ क्या हो जाएगा, हाइट, सॉरी दूसरा जो हाइट है वो क्या होगा, बढ़ता जाएगा। यहाँ पे क्या था एफ ऑफ ए, यहाँ आ गया, जैसे यहाँ आया तो कितना हो गया, ए प्लस एच हो गया, तो क्या हो जाएगा एफ ऑफ ए प्लस एच। ठीक है, फिर क्या होगा, फिर क्या होगा एफ ऑफ ए प्लस 2h हो जाएगा। ठीक है, सी एच, फिर 2h, फिर 3h, ऐसे ऐसे बढ़ते बढ़ते क्या हो जाएगा एफ ऑफ ए प्लस, सी यार यहाँ पे एफ ऑफ ए था, यहाँ पे सेकेंड बार में एफ ऑफ एच हुआ, थर्ड बार में 2h है, फोर्थ बार में 3h होगा, तो एन बार में क्या होगा n-1h होगा। ठीक है, ओके। ओके, नाउ अब h क्या हमने निकाला, यहाँ पे देख सकते हैं h, व्हाट इज h वैल्यू, इफ दिस h कम्स हियर n विल कम हियर, सो वी कैन राइट नेक्स्ट लिमिट। अब h जो है हम हटा रहे हैं, h का वैल्यू रख रहे हैं डायरेक्ट, h इक्वल टू b माइनस ए, सो b माइनस ए अपॉन n आया। ठीक है, n क्या हो रहा है, n इज टेंडिंग टू इन्फिनिटी, n इज टेंडिंग टू इन्फिनिटी। ठीक है, देन हियर f ऑफ a प्लस f ऑफ a प्लस h प्लस f ऑफ a प्लस 2h प्लस f ऑफ a प्लस n-1 h। okay, now this b minus e is a constant, so it can come outside the limit, out of limit. b minus a limit n tends to infinity 1 upon n f of a plus f of a plus h plus, not to write this directly, we can write f of a plus n minus 1 into h. okay, so this expression, ये जो expression है इसी को, this expression is only defined as a definite integral as limit of sum. This is only definite integral as a limit of sum. Okay, so you can pause the video to note it down. This only we have to study. Okay, so we will solve one question based on this, so that for your better understanding, just you have to remember this formula, this expression you have to remember. Okay, so hope you have understood this concept. Based on this concept I am going to solve one question, easier question first I will take. See this question, a limit is a to b x dx, this one we have to find using limit as a sum. So directly will fit in the formula. What is the formula? That is b minus a limit n tends to infinity 1 upon n upon, what is that, f of a plus f of a plus h plus f of a plus 2h plus f of a plus n minus 1 h. Okay, Now what is b minus a? Here directly b minus b and a is given, so here b minus a value will remain as it is, that is b minus a. Okay, so limit n tends to infinity, 1 by n is there, 1 by n is there, so we'll write 1 by n. Now see f of a, f of a, here only x is there, so f of a will be what? A only, a plus f of a plus h. Put here a plus h, we will get a plus h only. Similarly a plus 2h, a plus 2h. Similarly we are going to get a plus n minus 1 h only. Okay. Okay. Now we can see here also a, in this term 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 also a. So how many times a is there? A is up to n times. Okay, so right here b minus a to limit n tends to infinity 1 by n upon a is n times, so it becomes total how many times? Na, total is Na plus. Now see h start from second term, not from first term, so h will take common here, h, see here is h plus here is 2h plus, like that it there will be 3h also, plus like that it is here n minus 1 into h. Okay, so b minus a upon, sorry not upon, limit n tends to infinity 1 upon n na plus, so everywhere h is there, see, so I'm going to take h as a common, h common I have taken. Now see here what is remaining? 1 plus 2 plus 3 plus, up to how many times? Up to n minus 1 times. Okay, now we know the formula for sum of the series of n terms. Here n is n minus 1, no need, means no problem. n minus 1 फॉर्मूला क्या होता है n टर्म का? 1 प्लस 2 प्लस 3 प्लस, ऐसा करके अगर n तक हो तो इसका फॉर्मूला क्या होता है? इसका सम क्या होता है? टोटल, डेट इज n इंटू n प्लस 1 अपॉन 2, ये होता है सम का फॉर्मूला। ओके, तो ये फॉर्मूला है, यूज़ करके हम आगे प्रोसीड करते हैं। हियर b माइनस a लिमिट n टेंड्स टू इन्फिनिटी 1 अपॉन n, एन ए प्लस h। अब ये देखिए 1 प्लस 2 प्लस 3 क्या लगाना? n, n क्या है? n माइनस 1, सो राइट हियर n माइनस 1, I'll give here one curly braces first, n minus 1 written, then n plus 1, my n is n minus 1, n minus 1 में प्लस 1 करें तो क्या बचेगा? n, n by 2। okay, once again b minus a I have to repeat here, b minus a limit n tends to infinity 1 upon n, then here n a plus, here h is there, h is there. Okay, so can we write h as a b minus a upon n? Yes, we can write, because we know h equal to b minus a upon n. Okay, so in place of h I'm going to write this b minus a upon n, so b minus a upon n I have written. Okay, into n minus 1 into n by 2. Okay, be careful, don't get confused. Now see here, this n and this n will get easily cancel out. Yes or no? You can see this n and this n I can cancel out. So the remaining I'm going to solve b minus a. Just to simplify it, you will get the answer. It is little bit lengthy, but when you will solve as a means when you solve the definite integral, it will be very easy. When you find the value, then it will be very easy in the closed interval. I told you, no, I told you to find this this concept, antiderivative. When you will find the antiderivative, that time it will be very easy. As a limit of sum, this is somewhat lengthy only. See here, so 1 by n. Now simplify it. 2 into a n. I take the LCM, so 2 a n plus b minus a into n minus 1 upon 2. So b minus a, limit n tends to infinity, 1 by n is there. Now see here, 2an plus, simplify it here, b in b minus a into n, it will be bn minus an. Now b minus a into minus 1, so it will be minus b plus a whole upon 2. Now b minus a limit n tends to infinity, 1 by n. Now see here, 2an and minus an will be an only, an plus bn, okay, here plus a minus b. So an plus bn I can write here, give here 2, and again here I can write here 2. Okay, now if I take n common, and then n will get cancelled out. B minus a limit n tends to, see here n and this n will get cancelled out. Once again, I will not go that much shortcut. So limit n tends to infinity. So here it will remain, if a plus b by 2, okay, a plus b by 2, and then n got cancelled out for this term, plus this term is remaining, a minus b upon 2n. Okay, till here you understood. So next, see what we had got. b minus a till somewhat blurring. So b minus a limit, see this one will come out of limit, a plus b came out of limit by 2, then inside limit n tends to infinity, and a minus b upon 2n. N tends to infinity, so it will become 0. Okay, here plus will come, this term limit n to, and then here a minus b into a minus b upon 2n. Here n tends to infinity is there, so this will become 0. Okay, so remaining is this much only. So b minus a and a plus b, so this is nothing but b square minus a square upon 2. So this is the answer. If you will solve the same thing using antiderivative, you will get the same answer. Okay, like that, please first solve the example, and then only go for exercise. Please first understand the concept, slowly go for the example. Okay, then only exercise. Anyway, tomorrow we will do another question. Thank you very much. If you have not understood, please once again repeat the video, watch it. Even if not, then comment me where you have not understood. I will come to you in WhatsApp.